Right, just about 2 minutes after 11 o'clock. Thank you for tuning in. I am going to enjoy this next conversation because I love things from outer space. I was alive when we landed on the moon, Robin.
Me too.
And I say we because I like to figure that when somebody landed on the moon, then so did I. That's the way I look at it. That was such an exciting time back in those days. You know, people who are a lot younger than us will often say to us that I don't understand it. Why is it such a big deal for you when a rocket goes up? Every time a rocket goes up, I look southeast.
Me too.
Because I want to see if I can see it, and sometimes
I love it.
And sometimes I can. For the sake of our guest, he might not know he's speaking to us in Central Florida, which is where we are. Dr. C. Alex Young is on the phone. He has been waiting, by the way, through the break. So
Nice
I appreciate the
fellow.
patience. He is the Associate Director for Science in the Heliophysics Science Division at NASA's Goddard Space Flight Center. And one of the things we want to talk about is the total eclipse, the total solar eclipse happening 1 month from today, right?
Yeah.
You're going to be in New York that day, right?
Yes, I am.
And I'm going to be here in
Manhattan.
Florida, but neither one of those places is like the hotspot for the eclipse. You got to be like in South Carolina or something, right?
Yeah.
Dr. Young, what an honor. Good morning, sir. Thank you for waiting through all of that.
Hey, it's a pleasure to talk to you both, and I haven't been back to Florida in a while, and hope to come down your way sometime soon. I actually went to school in Tallahassee, so.
Is that right? Where are you right now?
I'm in Greenbelt, Maryland, just outside of D.C.
Oh my gosh! So you're in a pretty good place, right? You're pretty close to where you should be able to see a full eclipse. Or...
We're not too bad. We're about 85% here, but I'm actually going to travel down to Charleston, South Carolina, so I can be in the path of totality.
Really? Did you hear or read the story about the couple that's going to get married right at that 2-minute window?
I did not hear that. That's really sweet. That's really cool.
That's cool.
Yeah, I mean, married at night in the middle of the day. Will it? I mean, for us here in Ocala, I heard we have a planetarium at the Santa Fe College, not too far from here, and the gentleman who runs the show, he's unbelievable. You and he would talk the same language, but he said we will have about 80%. What does that mean? It'll feel like
So you're going to get about 80. It's actually 86% of the sun will be covered where you are, and that's actually slightly more than where I am. So it's pretty good. It's not totality, and I will say that if you have a chance to get to totality, it is like night and day. I mean, it is 99% and 100 are very different, but you guys are still going to see something really cool. I mean, the temperature is going to change, the light is going to change around you, and it is definitely going to be a really exciting thing that's going to happen over a couple hours.
But even if you were in Charleston, you can't look at it, right? It's still dangerous for your eyes?
The only time you can look at it safely is that very brief window of about 2 to 2.5 minutes during totality. Then it's completely safe. It's no brighter than a full moon. But any other time, even when the sun is 99% covered, it is not safe to look at the sun. It's just too bright. So at that point, you want to have either safe solar viewing glasses, or you want to use some sort of indirect method like projecting onto a piece of paper or something like that.
There was a story this morning in the news, and I didn't know it was there, but I guess on Google Street View, you can now take Street View into the space station. Did you see that?
I did not know that. That's pretty cool.
Yeah.
Neat.
You can walk, and I haven't done it yet, but I'm so anxious to do this because I want to look out the window. I mean, that is so cool. So, have you done this? Are you an astronaut? Have you flown in the space shuttle?
I am not. You know, I would love to do that. I've worked for astronauts. I mean, I'm a solar scientist, so I've been studying the sun all my professional career. I actually was interested in being an astronaut, but did not become one, did not try out to become one, and so I just have to live vicariously through others just like you guys. You know, we get to see these rocket launches, which I heard you talk about how amazing they are. Every time I see one, it's it's like it's like the first time.
Yeah,
I mean, they're
I don't,
unbelievable.
I don't understand why the younger kids are well, I'm not a kid, but I'm 62, just so you know, so is Robin. But I don't know why it's not so fascinating to them. Why?
I don't either. I mean, I'm 48. I've been, I was just a wee lad when they landed on the moon, but space has still been part of my life for as long as I can remember.
Well, it was pretty exciting that night because we were at a party with my folks' friends with all the children and everything and all the neighbors, and he brought his television set outside, strung it through the window and everything, so everybody there could watch this phenomenal event, and it was just so amazing. We were all spellbound.
See, when you call it when you call it a television set, I'm trying to do a joke here. When you call it a television set, then you know we're old. That's how you know we're old.
Oh yeah. Well, I was shocked. I was thinking about technology. I go into the classroom and talk about magnetic fields on the sun. These are the kinds of things you can actually see, during the total eclipse. And I was talking about the phone cords getting all twisted up, and I realized that I was talking to these folks that had never even seen a phone with a cord.
All right, I have a question about the importance for you, for scientists. The one question I have, well, before you tell me why it's important, I have a second question. I'll ask it first. The second question is, in the space station, can they artificially create an eclipse to help you maybe study the eclipses? I don't know.
That's a good question. They can't, because in the grand scheme of things, even though the space station is really big, it's still way too small to make any sort of significant shadow here on the Earth. So, in that sense, no. Now, they can see the shadow from the space station. They can even sometimes observe an eclipse. But that shadow is moving at about 1,500 miles an hour across the country. So even for the astronauts, they get an unbelievable view, but they still only have a small amount of time that they can really see it.
So what are they looking for, and what are you looking for here on Earth? What are the scientists actually looking for? And do you just have that 2 minutes? Does everything have to be right?
It does. It depends on what you're doing. So now, if you're studying the corona of the sun, this is the outer atmosphere of the sun, then that 2 minute window is the only time you can see it. But what makes this eclipse special is because it's happening over, the path of totality is going from coast to coast. You can put up telescopes all along the path, and you can take individual observations of 2 minutes, but you string them all together, and then you basically get one giant observation of an hour and a half. So that's what makes this eclipse special in terms of looking at the sun. But actually, you don't just have to worry about totality in terms of doing other kinds of science. You can do science by studying the impact of the change in light over the whole country. So even down where you are and farther south, we still see a change in the amount of light that reaches the ground, and that affects the atmosphere. That affects clouds and temperature. So we're studying not just the sun, but also changes on the Earth. And what's even cooler is that because we are interested in the partial eclipse for this, everybody who's under the partial, which is everybody in North America, can actually help us by doing citizen science. They can actually download an app and take an observation and be a NASA scientist for the day and help us. So we have an...
You just touched the nerd in me. I got a nerd. Oh, really? So
this is an amazing event. So if you go to eclipse2017.nasa.gov, which is our website, you can find an app called Globe Observer. And the goal of that is to record the changes that everyone sees where they are in the environment, clouds, measuring temperature, this sort of thing. And so we're gathering all that data from all of the citizen scientists across the country, which is helping us immensely to truly better study and understand the Earth itself.
And what was the website again?
We're able to actually understand the Earth itself by having all of these citizen scientists work with us and be NASA scientists for a day to give us that information.
And it's eclipse2017.nasa.gov.
That's it. Okay.
Yes,
Thank
that's
you.
it.
One of the things I found interesting from your press materials is that it read the eclipse is a type of transit, and that you could detect planets orbiting other stars, and that was pretty fascinating to me.
That's exactly true. So, when a planet or a moon moves in front of a star like the sun, we call that a transit. Now, if it happens to block out a significant portion of the sun or even completely, we call that an eclipse. But eclipse is basically a special type of transit. So the way we find planets in other solar systems outside of our own is we actually look at stars and we see the light from those stars decrease for a short amount of time and then go back to normal. And what we know is that means that something has passed in front of that star. And so depending on how much that light increases, how much that light decreases, that tells us how big that planet is. And that's how we've found thousands of other planets beyond our solar system.
Do you know what I don't understand? Okay, this guy Elon Musk, right? All right.
Yeah.
He wants to go to Mars. Okay, I'm fine with so far. Okay. And then he says, well, Mars is a pretty barren planet, but we can make it better. We can put plants there. We can make it all grow. I'm okay with any of that. But why can't we do it in the Sahara Desert? Why don't we just do it here?
There you go.
Well, I suppose we could. I mean, there are certainly people that have come up with ways to try to get water. We've talked to, people have done a lot of work on that. So, I guess that's a really good question.
I have a couple questions unrelated to the eclipse. But the listeners, if you have any questions, please don't hesitate to call. The number is 622-9622. I went to the website, by the way, eclipse2017.nasa.gov. And it's got a countdown, 31 hours and 50 minutes.
This is cool.
31 hours and 49 minutes. So it just changed. Okay. So with NASA being a government agency, and what Elon Musk has SpaceX, or is that another guy? Are there two private?
No, that's
agencies?
right. Yeah. Well, there's SpaceX, but then there's also Virgin Galactic, for example, which is the Sir Richard Branson's organization.
Oh, right, yeah. He's a wild guy, isn't he?
But yeah, SpaceX is Elon Musk.
So does that affect NASA's work, or does it interfere with it? Does it help it? What is the relationship?
It helps it. Absolutely, it helps it. I mean, there are a lot of NASA engineers and scientists that work with Elon Musk and vice versa. I mean, they are working to decrease the cost of putting things into space. I mean, right now, it's typically about $10,000 a pound to put something in space. That's incredibly expensive. And so one of his first goals is, how do we make that cheaper? And that's important for NASA, because if they can do that, then they work with us to provide a service to NASA to help us put things and eventually people onto the space station. So it is definitely a symbiotic relationship. I mean, we definitely work together and benefit each other, and so it is not a competition at all in that sense.
Dr. C. Alex Young is our guest. It's such an honor to have you on the show, sir. And we do take phone calls. And are you okay with that?
Yes, sir. Absolutely.
Okay, let's go to the phone. Good morning. You're on the air with Dr. Young.
Yes, thank you. Anywhere on the planet during the eclipse, could there be any kind of a possible weather incident?
Not, as far as we know, nothing caused by the eclipse. Now, it is the case that as that shadow is passing across the country, it does, for a short period of time, decrease the amount of sunlight. It does impact clouds and change temperatures, but that shadow is moving very quickly. So while there is a change, it's not a huge change, and it's not really generally a long-lasting change. Having said that, this is something new going across the U.S. like this. It hasn't happened since 1918, so we haven't really seen this for a while. So, being a scientist, I can't say no, there's not going to be something different happening, but as far as we know, based on all the science that we understand, there's no reason to expect any kind of weather anomaly or anything like that from the eclipse.
Thank you for the call.
We were told that you're working on a project about touching the sun. Larry had something about that in his news a couple weeks ago, and that's your project. That's pretty awesome.
That is that is a NASA heliophysics project, which is the area that I work in. We are unbelievably excited because for the first time next year, we're going to be launching a spacecraft that is going to go to the sun and touch the sun. We're going to be there up close and personal. We're looking at this. We've been looking at the corona and the sun's atmosphere from space and from the ground for decades. And even during the eclipse, we can see that, but we've never been there. We've always looked at it from a distance. We're sending a spacecraft there.
How close can you get before it's too hot and everything explodes?
We're gonna be getting within about 9 million miles, which sounds like a long way, but it's actually really close.
How close? How far are we? How far are we from the sun?
We are 93 million miles away from the sun.
It's amazing.
Wow.
It's just amazing to me. All right, let's go back to the phone. Thank you for calling and for waiting. You're on the air with Dr. Alex Young.
Dr. Young, wow. I wish I had the kind of brain that you had, but you have, but I don't. So for that, I'm very sad. But I'm wondering, and I thank you for all that you and all this wonderful scientists do to help us with everything. Do other countries have programs like we do? I'm sure I could Google this, but do other countries get into space programs like this? Because, I don't hear about them, and if they do, other than Russia, is there any collaboration with them?
Absolutely is. So there are a couple of, the Canadians have a space agency. Several countries have space agencies. Canada is someone we work with greatly. ESA, so that's a collaboration between European nations. The European Space Agency is another example. And then very notably, there's JAXA, which is the Japanese Space Agency. All of those organizations participate with our human spaceflight program, as well as launching missions into space. We have many joint missions to study other planets, to study the sun, and even the Earth. So there are very, very, very important relationships that we have and have been part of NASA for a long time.
Thank you for the call. I have a question about the light from the sun. I guess as kids, we all learned about the spectrum and about the prism. But there was one, I have a vague memory of a teacher telling us that there was more to the spectrum than what we see. It's just that there's only certain colors we can see, but there are actually other wavelengths. Is that important for you as a scientist? And is it even true?
That is true, and it's very important. So in fact, the spectrum of light is actually much, much bigger than what we can see with our eyes. We see a very narrow portion of it. So there are things like radio waves, X-rays, gamma rays. These are all parts of the spectrum that we don't see with our eyes. But they tell us a huge amount of information about not only the other planets, the sun itself, but even other stars, galaxies, and parts of the universe. So it's actually very important that we look out into space in all of these different wavelengths, because they all tell us something very different. The issue for us is that our atmosphere is very thick, and meaning that there's a lot of it between us and space. And that's actually a good thing, because things like X-rays and gamma rays are not healthy for us.
You're right.
And they're stopped by the atmosphere. So, but what that means is we can't see through it in those wavelengths, even with a telescope. So we have to put stuff into space.
Is the Hubble still a viable entity, or has technology surpassed that?
the Hubble is still going strong. I mean, that's one of the cornerstones of NASA, is that while we generally make missions that last and are designed to last for a few years on average, many of our missions, the Hubble is the main example of this, but there's also Voyager, which has now reached the edge of our solar system, and even the SOHO spacecraft, which is a NASA ESA program looking at the sun. These missions have lasted for many years, and the Hubble continues to send back, amazing, incredibly useful data, and it will continue for years to come. And then we're launching the next generation telescope, the James Webb spacecraft, the James Webb Space Telescope next year, which will expand and extend what the Hubble has provided and give us even newer views into the universe.
Wow.
This is so exciting.
Yeah, every once in a while there'll be something on the internet. It'll show like a tiny microscopic portion of the sky. And then it'll blow it up and it'll say, look, this is a million zillion galaxies. It's like,
exactly.
Holy man.
Yeah, I mean, that's called the deep field view from Hubble, and to me that is one of the most amazing images I've ever seen. It's just unbelievable.
So when you are looking out into the other suns, the other stars, by the way, is this true that the only natural satellite, and the only star that we have that are not named are our own? Like the sun is not really the name. We don't have a name for the sun?
Right. Well, the name, as far as I understand, the official name of the sun is Sol, S-O-L.
Oh, okay.
So the sun is actually not a proper noun, and it's the same for the moon.
Isn't that interesting?
Oh,
Well, we call it the moon, yeah. The moon and the sun. Okay, so when you're looking at other suns, other stars, does the color of that other sun tell you what it's made out of and how hot it is and all that other stuff?
It does. Exactly, it does. So when we look at other stars, we actually found years ago some scientists basically took data from stars, from different colors of stars, and figured out that there was, when they put them on a little graph and plotted them out, they realized there was a pattern, and it's called the Hertzsprung-Russell diagram. And that actually shows us that the different colors of different stars tell us about how big they are, how old they are, and what they're made of. So looking at stars in different kinds of light, different colors of light, is really important for helping us figure out what we're looking at.
When you make discoveries, how much data do you need to prove whatever it is for each discovery that you make? Do you do like tests with a computer, or how does that work?
Well, it's an iterative process. I mean, we look at an object, we gather data in as many different wavelengths as we can, and maybe even things besides light. We look at gravity waves or other particles besides light to figure out what's going on. But then we have to take that and then take physical models and physics that we've figured out and develop these computer models, and we combine the data with those, and we see, how closely they agree. And then when we see discrepancies, we have to go back and take additional measurements and then sort of fine-tune things. So it's actually an ongoing and in some ways a never-ending process. We're always fine-tuning what we see and our description of things out there. And so we can get more and more certain, but we'll never know absolutely. But that's really part of what's important about science. I mean, when we talk about theories are actually things that we've well established by taking observations, making sure they match what we have on paper and in computers, and then we just continue to fine-tune that process over and over again to get a clearer and clearer picture.
Everybody's so interested in the Eclipse that even Royal Caribbean cruise lines, they have a package. I am not making this up. They do. They will take you out to sea, and they'll be right in the line of the Eclipse at that very moment. So 1 month from today.
That would be a fun cruise.
That would be fun, yes. All right, let me squeeze in one more phone call real quickly. Good morning. Thank you for calling. You're on there with Dr. Young.
Good morning, Larry Ross. Hi, Dr. Young. I had a quick question. Hopefully it wasn't asked already. Is the sun moving with the Earth, or sun moving closer to each other or further away? And if so, that alone, what impact does that have on that climate change or global warming that we all hear about?
Both the Earth and the Sun are moving together because the whole solar system is moving. But in terms of the Earth and Sun as a system, they're pretty stable. I mean, the Earth is moving around the Sun, and there are certainly times when it's closer or farther away, but that process over the year is pretty stable. So there isn't a lot of change between the distance. And we feel we feel confident understanding our physics that that's not going to change. And so what we've been able to figure out is that the sun, while is the heat source and the driver for our weather and our climate, it's not actually what's causing changes in our climate. So the changes we see in our climate, we know the sun is not a factor. We do know there are natural changes, but the changes we see in our climate are not due to all the natural factors that we've looked at.
Wow, what an interesting conversation we've had. I guess I have only one more question. Is there someplace I can go on the planet where I can actually trick like a native king to allow me to marry the native princess just by telling him, that there's going to be a dark moment if you don't
If you don't allow me to marry her.
Well, I can definitely say that we've mapped out, one of the things that NASA scientists have done and scientists around the world is we've mapped out eclipses for the next 5,000 years. So given that data, you can go around and find a spot, sometime in the next 5,000 years, you might be able to work that out.
You're a lot of fun. My goodness. Thank you for being on the air and for doing this whole thing with us. I know it was a long interview, but we certainly have enjoyed it. I want to remind the listeners, if you want to get the app that Dr. Young talked about, go to eclipse2017.nasa.gov, and we'll attach that to this as we put it up as a podcast as well. Dr. C. Alex Young, what an honor. Thank you so much for sharing your...
Hey, it's been a pleasure, and anytime you guys want to chat about science and space science, I would love to.
Absolutely. If you're ever down here and there's a rocket going up, come down and help us.
We'll show you the best place to view it from.
You bet.
Oh, actually,
I'll do it,
and
definitely.
And the Kennedy Space Center is having an eclipse party, by the way.
Yeah.
Yeah, if you want to go over.
Good.
If you want to go over
Good.
there. All right. Thank you, Doctor. All right. We will take a little break. We'll be right back.